Yeah, Kira, I'm Huss. As Reen said, I did a productivity study on the harvest line cable yarding system. Machines built by EMS Rotorua, and there are around 60 working in the world at the moment. So the machines are built by converting already existing excavator bases into the harvest line, so putting on the harvest line kit, or completely modifying the excavator base from ground up. These machines are coupled with the Hawkeye grapple system, as you can see here, that little red bit over there. And then the tail hold can be a stump or a moving bulldozer or another excavator. So to give you a bit of background as to why I did this study, plantation forests in New Zealand are in steppe country or in smaller restricted woodlots. This is also true for some parts of the world like South America, Japan, Canada, and Scotland. For these steep slope extractions, we have used bigger cable yarders, but they can be expensive to set up and to operate. Mainly due to the logistics of moving such a yarder on site or the time taken to set up guidelines and stuff. There are also some environmental and safety concerns that still dictate we use cable yarders on these sites. I think this is where the harvest line comes in with its unique capabilities and its size. But there has been very little research on a harvest line system. So with the help of Reen here and Chris Hancock at EMS Rotorua, I studied 3 similar harvest lines working in 3 different settings. And then I compared these machines to better understand the capabilities. Yeah, I did time studies using a stopwatch in Mosgiel, Rotorua, and Abeyratne. Time taken to complete each element within the work cycle was recorded here, and then taking some measurements like extraction distance and stem size. I also attached a GPS to the carriage to represent the carriage going out and coming back in, shown there, as well as calculate carriage speed going out and coming in. Looking at Mosgiel, the crew working here was Rotorua contracting, and they were working for Abeyratne Forests. You can see some of the results here, and the productivity was 86 tonne per productive machine hour. You'll see soon that this is the highest of the 3 studies I've done. Yeah, so there were 2 major delays here. The first one lasted 2.5 hours, and this was due to a cracked diesel pipe on the carriage, which was remedied on site. The second was a yarder shift that lasted hour and a half, so 1 hour 30 minutes, and they had to move the tail hold, get it onto the logging road, and go around the forest. Looking at Rotorua, the crew working here was Harper Logging. The productivity was 77 tonnes per productive machine hour. This is lower than Mosgiel, potentially due to this slower carriage out times, out speed, and also this crew was cleaning up these gullies, so they were pulling up slash and stuff as well. There was one major delay here lasting 1 hour 10 minutes, and this was a tail hold shift. Something interesting here was that Lawrence of Harper Logging, he used a fishing drone to hook up the straw line and send it over to the tail hold, which is pretty cool, I thought. And Abeyratne, it was SDR Logging working for Dodds Forestry. As you can see, the productivity here was the lowest due to the longer extraction distance, despite the bit higher piece size. There were 2 major delays here, one lasting 1 hour 10 minutes when they were shifting the tail hold going from so here to 220 meters up to 440. And then the second, due to a snapped main line, which was quite major, lasted 1 hour 30 minutes. And they fixed that on site as well by cutting off the broken end and splicing connection on site. Yeah, so looking at all these results together, you can see the different productivities. These differences could occur due to how the crew is employed on site. So in Moskill, they were doing that whole extraction using the harvest line. In Rotorua, they were used to clean up those gullies. And in Moskill, they were working in that woodlot. Also due to the difference in extraction distances and piece size. Yeah, looking at some of the analysis of data, starting with a sort of a bit of obvious one, I guess. When the extraction distance went up, the cycle times went up. This was true for all 3 studies. And another thing I found quite interesting was the hook-on time. The most variation in the hook-on time was in the middle of the extraction cycle. So sort of the carriage would be in the gullies in the middle, and that's where it was deflecting the most and moving around the most, making it harder to hook onto a log. Yeah. Looking at the productivity, it decreased as the extraction distance went out, as we would expect. And these zeros here, I'm not sure how to point it on the screen. I don't know if you guys can see that, but those zeros here was mainly in Rotorua, where they were cleaning up the gullies, as I said. So they'd go out, pick up slash and tops that couldn't actually be turned into logs. So a 0 productivity there. Some things I saw. From all the 3 studies, the P size varied from 0.4 ton to 4 ton. Another thing was that the operators could make small adjustments to the extracting corridor by moving left and right or swinging left and right. This was quite important in Moskill because the tailhold operator was also driving the skidder. So if he had to go out to move the tailhold, he'd be away from skidding duties. So sort of breaking up that production line. Another thing was that the carriages got night cameras. In forestry, we like our early morning, so it was quite important to have that low visibility option. Yeah, another thing was the carriage was shotgun down to decrease the time taken to reach certain extraction distance. How this was done was that on the previous loaded run, the operator would keep an eye out on the cameras onto a log that he could see on the extracting corridor, and then on the next run, he'll just gun it down to that log, pick it up, decreasing the cycle times. Yeah, another thing, it's real easy to use. Interlocking drum system, 2 buttons, 2 pedals, real easy. Yeah, to sum it up, like I said, it worked in company forest doing the whole extraction. It worked in Rotorua, where it was cleaning up those gullies, and in Moskill, in that woodlot, still extracting out to 180 meters. Had quite short cycle times, minute 48 seconds on average. It's very mobile, like I said, move around, expanding those extraction corridors, and this was due to the lack of guy lines, also quite easy to set up. Yeah, and worked well in space restrictions, and this was seen in the Potiki, where they were there the whole time, the whole of extracting all of these stems up there. Yeah, all whilst being quite productive. So, yeah.
All right, thank you very much. Okay, nice classic productivity study. So yeah, questions, Mr. Harvey?
I've got a question about felling and setting out for extraction. We didn't really cover anything to do with labs. What's the effect? Bunching and unbunched.
So the question was the felling. Huston mentioned how the timber was felled and what would be his perception around whether it was, if it was bunched.
Yeah, so all 3 studies of timber was manually felled. Yeah, so, and they were presented quite well. So yeah, yeah, made the extraction quite easy, but bunching with that sort of piece size would have been a bit difficult unless it was bunched in 3 stem max. Sort of, yeah.
Okay, another question.
Yeah, I've got a question for you, Huss, Keith here in Rotorua.
Okay.
Congratulations on a good study there. Obviously, there's been very little data in the past on excavator-based yardas, so great study that you've added to the industry knowledge. So yeah, congratulations on that. Also, I guess in the past, you know, we always considered that the line speed was a limiting factor for those excavator-based yardas. So it was good to see that you incorporated and got some good results on, you know, travel empty, travel loaded line speeds, which are quite surprisingly fast. So I think that's definitely added to, you know, the industry knowledge around the harvest line yarder. I had a question. You put the piece size in there, but you didn't include the payload. So we don't have any idea of the number of stems that were on each of the drags or what the payload might have been, because that was another, I guess, limiting factor with those kind of machines as opposed to, you know, the larger tower yardas and swing yardas. From your data, can you extract that information on payload?
Yeah, so on my big Excel sheet, I've actually got all the number of stems that they extracted. So yeah, I've got that data. I didn't include it in here, but yeah, it's on average like 2 stems, usually 1, but the high would be sort of 2, 3.
Okay. No, that's really good. The other thing that I think you've picked up on, which is really useful, is the benefit around you know, the fact that these yardas have no guy lines, are particularly well suited for you know, small landings, maybe roadside operations, and have that ability to swing the load, you know, left and right with the you know, with the rotation of the base machine. With your final sort of results, can you include any sort of recommendations for industry about the potential of the excavator based or the harvest line and specifically?
Yeah, I'd say they work well in, like I said, all pretty much the whole range of settings. I think it's, if you can't move a bigger yarda into a restricted setting, or when there's space limited, yeah, it's harvest line country then. So I think.
Excellent. Yeah. And maybe one last question around your productivity results are in tonnes per productive machine hour and scheduled hour, and you recorded some delays. Did you get a figure for the utilisation of the machines that you studied?
Yeah, it was around the 60% mark, low 60s.
Okay. Now that's pretty typical, I guess, of a lot of cable operations in New Zealand. So that's another key factor, I guess, that that shows the capability of these machines. So yeah, well done. Good study.
Thanks, Kit. Cheers.
Yeah. All right, one more question, Mr. Wells.
Yeah, did you look at the terrain and the flexion of it as part of the study? The only reason I say they look like pretty magic stems from harvest line.
Not quite deflection. I didn't measure the deflection. Yeah.
But it'd be interesting to see some results at the end of the normal operating envelope for the harvest lines.
Yeah.
And compare that productivity as well.
Yeah, that's right.
Yeah, so sorry for the Zoom audience. So Barry Welsh just probably noticed that the settings that Huss presented here have been really quite ideal for a harvest line, whereby the Opotiki one was out 440 metres.
Yeah, the tower.
Going across the native. So we do have some numbers around the more challenging terrain as well as when deflection started to get low, but it is a fair comment. It is 3 relatively new harvest lines in 3 good settings with 3 good crews to look at the potential of the harvest lines under very good conditions. Yeah.
Was that pulling with 400 metres or just tied out?
Tied out 400 metres, it was pulling 250. They would have actually pulled out way further, but there was a patch of natives they couldn't pull on. So,
Thank you.
I've got a quick question, if that's okay, Reen.
That's fine, Rob.
Just you mentioned the system they were using was shotgun. With these harvest lines, they tend to use running a skyline. Was it a shotgun system they were using or running skyline?
no, yeah, it was running skyline, but maybe what I meant to say was that they just release the carriage and it will just zoom down rather than being a sort of a controlled.
All right.
Yeah. So it was a running skyline.
Oh, okay. Thanks for clarifying that.
Yeah.
And congratulations. Good presentation.
Thank you. Cheers.
Okay, thank you very much. Us here, we'll just keep it on schedule.